Hello everybody, thanks for coming back to the channel. I've got a repair for you today, and this machine was sent to me by none other than Gadget UK. I'm sure you've all seen this channel. Everything I learned from watching this channel. So first of all, thanks very much to Gadget UK 164, and also thanks to a guy called Zarkos or Xavier. He was the guy who sent a bunch of these machines to Gadget in the first place. This machine's pretty heavily damaged. The battery damage is up to about here. It featured in Gadget's video, Archimedes A3000 repair from hell. I'm not going to do a blow-by-blow account of this repair because it would just go on forever, but I'm going to focus on some of the trace repair, some of the components that were damaged, basically the nitty-gritty level of damage that you might have to think about dealing with if you're going to do one of these machines. There'll also be a thread linked in the description. I'm going to speed through quite a lot of it because otherwise there'd be too much of it, but hopefully it will serve as a useful repository of information for anyone else mad enough to want to repair an Acorn Archimedes A3000. The keyboards are normally absolutely minging. These ribbons, they get welded to this with battery acid, and so when you pull them out, you lose all of the conductivity on there. This is probably one of the worst ones I've seen. The battery acid has gone quite a long way. It's gone right up to here, under there, it's got under here. This area is obviously completely shot. All of this is going to have to come off. These are the ROMs, these are all going to have to come off. The CMOS chip is going to have to come off. The crystal is probably going to have to come off. Definitely the keyboard ribbon connectors are going to have to come off and be replaced. Socket is going to have to come out. I'm going to take the power supply out, which is disconnected, so you've got 5 volts. And to get to that, we're going to open up here, undo a screw, pull the whole lot out, and that'll be that. Take the speakers out and take the board out, and what I want to do is just hit this with vinegar, white vinegar, stop the rot. If we don't stop it, it's just going to carry on rotting. White vinegar and then isopropyl, and then at least we've got it stable. Check the power supply. You don't want to touch the underside of it. There's nothing on there. And the other one's here, and there's nothing on there. Next up, we take this out and the earth. Now we can remove the power supply. It needs this insulation. First, let's get the drive out. It's going to be a screw there, screw there, screw there, screw there. And as you can see, that is clean as you like. They just lift out like that. That was clipped under there, clipped under there. And the other speaker is exactly the same. It just lifts out like that. Where the screws are. So there's one there, one here. Okay, so that's it. We've got a nice spider web underneath the main board there. Okay, so we're ready for the clean-up procedure, which will involve white vinegar. You can use a toothbrush, but I'm going to use an anti-static brush. So I thought it'd be interesting just to have a look at how this goes under the microscope. And you can see why, even cleaning those up, they're still rough. And they're going to damage the ribbon connector. ROM sockets, close up. It's quite beautiful in a way. The solder mask is actually bubbled up. This damage is so insidious because you can fix what you can see and think, oh, that's all right, I fixed it. But then 10 minutes later, something that was just holding on can let go and it's back to square one. So that's the back paint. Pretty much just so that ain't it for the cleanup, but that will stop the rot. It's about 2 hours later, and you can see why this is such a nightmare. So what I'm going to do now is go over it with the vinegar again, this time abrasively with a cotton bud. Okay, that's 2 passes and cleans with the isopropyl and the vinegar, or the vinegar then the isopropyl, and this fiberglass pen. We've still got this white stuff everywhere. So I'm going to tackle this is go for the worst one first, which is probably going to be this one or this one. See, what's happened here is that all the solder has got mixed with the battery acid and it turns into this kind of white gunky crap. So putting it in like that, warming it up, giving it a wiggle. Using gadget tricks on a gadget boards. That one's as good as gold. Let's try this one. So these are coming off remarkably easily. Okay, so next let's try to get some of these bits here off. I think these are going to be pigs. Thread it on the bottom of the board, but we don't thread it on the top. So what I'm doing is going in between the leg, bending one against the other. Okay, so that side's out on that chip. This side isn't quite. What you don't want to do is tear it up, because if you tear it up, you're only going to have to fix it. So again, we don't want to be forcing it. Okay, you might even be able to salvage these. But look under here, look. Okay, so it's next day now. You can see the amount of white battery acid still on here. And you saw what I put on there in terms of vinegar and isopropyl. But I mean, it just don't stop. You're going to go up here. Look, all of these chips have got it, and it's on all of these as well. It's like soaked into the board. So this same battery acid that started here has got to here, and it's got all the way up to here and here. It's probably got under here, and it's probably got under the processor. It's on the legs over here, right on the other side of the board. And you can see it here, look, under here, right over here on the switch, the power switch. Given the state of everything I've seen on this board so far, I cannot leave this on here. You saw how bad it was caked up here, down here. I mean, there's no way it's not caked under here. We just need to get a bit of flux down here. That's how bad it warped. Okay, it's off. Let me go around the CPU here. There we go, just let that cool down naturally. This is under the arm chip, so you can see I've reflowed those. I'm going to fill these vias and these traces where they're crappy, like see they're all crappy here. The battery acid's got on them, that's solder mask, it should be protecting the copper, but it's just bubbled off. Some of these tracks you'll see that they're broken, others the breaks are so small you just have to buzz them out with continuity. See the colour of it? It's dark. Because it's reacted with the battery acid, it's going to just need completely bridging with wire. So these tracks here are original, and these tracks here where I've scraped it away. And you can see they vary in condition. Some of them down towards here are very, very, very corroded and will need replacing. So you get the idea, I'll come back in a minute. You can see I've coated these tracks with solder. Some of them work, some of them don't. Some of them take solder, some of them don't. And some of them look like they're connected, and they're not. They actually break right at the joint here. So the next stage, get some magnet wire, and then use the magnet wire to remake those traces. So I've got the magnet wire poked in there, held in with some tweezers under pressure. So basically, tagging magnet wire onto the trace, and then we take the blue tack off. So you can see all of these little traces that I've repaired there, where they were all a bit dull and crappy. And likewise the CPU here, you can see the difference between, say, these and these. A lot of them are broken, just where they go into the eye. Obviously I'll unblock these. The magnet wire has to follow the track and then go through the hole. It's next day now, and I think we've got to change the tack with this board. Share some of the lights here. These are the memory control resistors, or near them. They're supposed to be 68 ohms. And this is after I've scratched all of the surface corrosion off, cleaned with vinegar 4 or 5 times. 1.163 kilo ohms. 0.981 kilo ohms. These are supposed to be 68 ohms. 2.213 kilo ohms. 2 kilo ohms. 2.6 kilo ohms. They're just like open line. Yeah, open line. 40k. It's open circuit. 10 kilo ohms. Now it's 76, 83, 92. See, we're at 100 now. 150. 1.2k. Just showing you why I've taken them off. This should be a 1k. It's a 1.2. 47k. That's 53k. This is a 4k7. It's 5.8k. It gives you a clue about how bad this whole shit show of a board really was, or is. All of these, those three, those, all of that, these, all of these, most of these up to about here. You see the old ones there. All of these are out of spec, these are out of spec, these are out of spec, over here is out of spec. I've got one piggybacked on top of the other, and it gives me roughly the right within 5% tolerance. This has been going on for about 3 days now, and I'll just show you where we are. All the memory's off, the CPU's off, the IO chip's off, all the ROMs are off. Obviously this area started with, right up to the internal expansion and the keyboard. All of these chips here are off as well. Pretty much reflowed all the vias, the entire area that I've taken out. So you can see, whereas before they were kind of you know, dull and kind of blurry, they're not so much anymore. So for example, you can see that here, I've done the magnet wire there, I've done the magnet wire. This a mouse trace, you can see I've thickened it up with solder. Up to here it's okay. Up to here it's okay. Not okay here though. Zero ohms. Some of these were showing really high resistance, so they'd show a continuity, but at like 20, 30 ohms. Where the damage mostly is where the eyelet meets the trace. Around near the IO chip, you can see some patchwork. Here, even up as far as here. Socketed this, socketed that, reflowed this. Change these, change these. So all of the surface mount caps are coming off, and I'm cleaning up underneath, testing them, and if they're okay, putting them back. So they're the speaker connectors. They're here, and the battery damage was here. I've lifted up all these diodes, gone underneath and reflowed them. I've taken off all the transistors, all the capacitors. I've checked under even all these red and yellow caps here. Reflowed all of these, reflowed pretty much everything. Taken off the RGB connector, taken off the composite video or monochrome video connector, taken off the audio connector. A lot of these tantalums were bad, these little tantalum drop capacitors. 40 ohms. The board's a lot cleaner now. Hopefully you can see that. These are all the transistors that are off. These are all covered in white fur, which is like the crystal battery acid. Those diodes, all of these have been off. I checked. Yeah, all the caps are off. And this little area has been cleaned up. All of these little film capacitors or polymer capacitors have been taken off. All of these SMD resistors, every single one. You can see here I've changed these caps. They're supposed to be axial, but I've just used a radial one bent over on itself. Okay, so I've got a few sockets on, but I think what I want to do next is get these on here. But because the board's warped, I don't want to end up in a situation where I'm putting this on last. I think I want to kind of at least offer this up and put this on first. And then as I put these ports on, you know, who knows, it might even help straighten the board out. I've cleaned up the ports, so this is the RGB port. I've checked continuity between each pin and the holes. This is the monochrome video port. Cleaned it up with vinegar and isopropyl. I just shoved a bit of sandpaper down the middle of it. And the same thing with the audio. Capacitors back on. I've taken off the components here, these capacitors. I'm going to check them. You know, I put all the caps on, all the transistors are back on, all nice shiny solder joints. I'm kind of like moving in towards the damaged area. These are right near the printer port. Taking all them off, swapped them for ceramics. And before I put the sockets on each one, I'm buzzing out the lines to make sure it's okay. You can see the bits of silver. That's where I've patched the traces up with solder. This pin here needed a wire from the VIA. Even up here, you can see there's quite a lot of patching up work being done. It starts getting really shitty down towards this area here. But some of these along here are still missing. I had to run a wire down from here, under here to here, because the pad had gone. Okay, so I want to get the processor on. Two things against me here. One is the board's warped. The other is that the processor was covered in battery acid. This goes on upside down, and you can see there is a little indentation. Camera will focus there. Lines up with this one here. Chip will actually sit on there. We've got to line up all these pins. It is actually pretty well lined up. Apply heat and then feed that in. Chips on, and then there's no bridges in between the pins. So hopefully you can see that I've got these sockets on here, got the processor on, got these sockets on here, and now I want to move towards the I/O chip. So I've checked all of the connections underneath it and to it and all the pins. One needed patching up, which was this top corner one here. Okay, so this is the I/O chip. I'll give it a little sand down on these legs. Some of these are tarnished. Pin 1 is aligned there, put that on there like that. I'd say that's fine. So what I'll do now is just tag one of these here. So then I'll just check all the other corners. Are still good. Moved it. Triple check. And just and now this is the really badly damaged bit. I've ticked off each pad where it goes to. Same again with the ROM tracks. You know, this was the I/O chip, this was the memory, this was the processor. So this guy goes from here to here to here. It sounds good, but I'll show you just from here to here, 23 ohms. That trace is now patched. Goes from here, up here. It's got a little eye loop made there. Then it goes up here. It doglegs here, and then it's terminated here where the trace goes good, less than an ohm. This is under the two chips that govern the keyboard. And these are all magnet wire links I've put. I've buzzed out all of those connections just to make sure that once I put the socket on I'm not in trouble, because it's not easy to fix these links. To be honest, look at that, I mean that's just crazy. To be honest, I probably shouldn't have done it this way. I should have done wires on the back. See, you've got wires under the socket there. And I've buzzed them out about 3 times, but before I put the sockets on I will buzz them out again. Yeah, see there's patch up work there. You see there's link wires there, there's bodge all over the place. And the next thing you'll see is sockets on here and ROM sockets on as well, and then repopulate the board. Okay, so apologies for the voiceover. You can see the board, a couple of bodge wires on the back because a magnet wire fell off. There it is assembled. There you can see the lovely warp in it, and here you can see it plugged in, and I put it all back together, turned it on, and I got sweet FA. Nothing. The screen goes black. It doesn't say no signal, but it doesn't say any clue at all. Now we've done that, the next thing is to look at the address lines. So what we're going to do is check ICs 29 to 30, looking for the elapsed address lines whilst we're holding it in reset. You'll see that the frequency will half as we step up each address line. Okay, so I've actually checked every signal line. So these are the address lines between the MEMC, the ARM2 and the other various chips. That's address lines, same thing, all the way across. I'll link this in the description. The data lines, everywhere they go, they've all been checked. And these are on the ARM, and between the ARM and the MEMC and the VID and the IOC. So these are 4 main chips, all traced out, and then we got between the keyboard and the IOC. So having done all of that, it still doesn't work. So the guys on Stardot suggested I get one of these. This is a POSTBox, and what it does is it's got an FPGA on it, and it connects to your computer, your laptop, by USB. You download some Python code, and it runs a self-test and a memory test. And it links and bytes onto various points on the A3000. Most Acorn machines have a proper test point. This one doesn't, so these connections are a bit how you're going. So you've got here, you've got ground, reset, acknowledge, request, data, and 0 and 5 volts. And I've labelled them all up where they go, so I'll put that in the description. And the idea is, if enough of the computer's working, it will start to post, and whatever it posts, this can decipher and give you a clue. So this unit's designed to plug straight into a test port, which they have on most Archimedes machines, but not this one. So I figured out the pin out, and that's what all these spider wires are doing. They're basically picking up the signals from the board where they are, and I'll list that in the description. But basically we've got 5 volts to the board, 5 volts to a laptop via USB to the POSTBox. Okay, so then I'll just put this command in, Python self-test. So let's turn on. Let's run that again. Oh yeah, blue screen, red screen, green screen. So that's what I was getting before. You can see, hopefully, we got pass 0001A. So it's supposed to draw squares on the screen to check the memory, and that's exactly what it's doing. I've got the board stripped of the POSTBox, so the board's just running on its own now. I turn it on while holding down my delete button. There we go. No keyboard present. Sorry about the camera angle. No keyboard present. So now you've just got to figure out why there's no keyboard present. I've put the Acorn branded A3051 chip back in because the one I had wasn't programmed, and now when I reset the machine, this is what I'm getting. So now it's trying to boot to the desktop, but it's not recognising any key presses, and that's what I'm getting. If I reset it, sometimes I get that, sometimes I get nothing, like that. Reset it again. Get that again. So it's trying to show a desktop, but I can't change the CMOS settings. Okay, so apologies. You're looking at the working Archimedes, and the reason you're looking at the working Archimedes is I think I've traced the no keyboard issue. I think I've traced it to this chip here, which when you look at it stands to reason because this chip is right near the battery and the battery leaked. I've taken this chip out of the working system and put the chip from the naughty system in there, and what we're supposed to get here is the keyboard has a clock, and the clock is on going in on pin 3 here, coming out on pin 5 here. Now I'll show you what that looks like on this machine with this chip in it. Okay, so this is the keyboard clock in on pin 3 of the dead chip, and this is the keyboard clock out on pin 5 of the dead chip. Nothing. I'm now going to swap it for the good chip. Okay, so I've put the good chip in now. So you see the clock signal there going in. And on 5 you can see the clock signal coming out, much bigger, 5 volts of division. And this is probably quite a bit later from the last video, and the reason for that is I just got so fed up with it I stopped making video. I've reflowed all of these, reflowed all of these, reflowed that, reflowed these, and reflowed all the RAMs because I was getting a RAM fault sometimes. And you can see it's working, the mouse is working, all the mouse buttons are working. But prior to that, the mouse was thinking one of the buttons was pressed, so I've swapped this capacitor C116, and I have, you know, banged this board. Problem is, I don't know whether one of the memory chips is slightly on the edge or what. Now it's thinking that this is the only RAM it's got, so it's completely ignoring this. I've undone the hack. Okay, so I think we're getting to the end of this video now, because otherwise it's going to go on and on. You can see I've put the thing back together. I've got the keyboard in, got the drive in, got the board back in, the power supply hooked up, and it is now booting all of the time with the 4 meg expansion bypassing the onboard memory. 4096, so that's all working. The mouse is obviously working. I've checked all the keys. And reboots, so for the camera angle. So that cursor's actually working. Memory in system sprite area. Doesn't think it's an original disk. So it's actually, I'm not very good at this, but it is actually working. So what I've done is I've chopped out the drive and put a Gotek drive in there. And as you can see, it's got Zarch working. I'm not very good at it, but it's working. Okay, so this game is Revolver, this one's working as well. I think it's something to do with the disc. It was weird, it was working with cover discs and non, I don't know what buttons are here. Oh, yeah, this is a weird one. You've got to kind of guide the ball like that. It's really left-handed for a camera, not the easiest thing in the world. Okay, so that one's working. So this is Paradroid 2000. This is working fine. I think it's confirmed it. So pretty much everything I'm throwing at this now is loading. I don't think there's much wrong with this at all. Okay, you see it's running. Okay, this is Spears of Chaos. This one's working fine as well. Okay, so I hope you enjoyed that. That's going to wrap it up for this video, because I'm going to consider that a win and stop there. What was wrong with this machine? Well, obviously a lot of battery damage, broken traces, extensive corrosion, but what ended up needed to be changed was the CMOS chip, the ROMs, because I've got new ones, the keyboard clock chip, the 8051, the keyboard controller, that was me being an idiot basically. The L1 works, so that wasn't damaged, but it can be. Most of the SMD resistors were just a write-off. Half the tantalum capacitors were a write-off. The mouse capacitor that I showed you, it's either C116 or C16. That was a nightmare because it was pressing the buttons even though it was testing fine. And then the thing that really got me was the flaky RAM chip. Now, whether that was a flaky RAM chip or whether it was a connection that was just, messed about with and I reflowed it and it worked, I don't know. I'm pretty sure it was a flaky RAM chip. And what I should have done, and what I didn't do, was leave the sockets on, like the gadget half-cut sockets on, and then I could have plugged in different RAMs. But to be honest, the way I did it was basically just to bypass the entire thing, and that way it's ruled out. You don't have to worry about it. So if you put a 4 megabyte expansion in this, it automatically bypasses that RAM. You won't have to do any of that messing around and hacking. I could not have fixed this machine without help from Gadget UK and without help from all the people on Stardot, and there was loads of people on Stardot, and they're all very, very helpful, and likewise the people on Gadget's Discord server. So I'm going to leave it there. I'm going to call that a win. You can see I've bought it at Gotek, but I'm not going to subject you to that. I also bought this for a ridiculous amount of money, and it just needed 2 LEDs in there to make the mouse work, and I'm not going to cover that because this video I think's gone on long enough. Would I sell this? Probably not, because I just don't want the blowback. It's working, it's fine, it's probably going to stay in my collection. So once again, thank you very, very much to Gadget UK. Thank you very, very much to Zarkos. Thank you very, very much to all the people on the Stardot forums. I could not have done this fix, and it has been an absolute mission. It's been emotional, But thanks for watching, take care, and I'll see you all soon. Cheers.